I'd like to invite our next speaker, who is Eoin Ryan. Eoin graduated from University College Dublin here in Ireland, and Eoin currently works in UCD. He is part of their herd health team, providing consultancy and referral service, and he's going to talk to us about bovine Besnoitiosis.
Thanks very much, Sally. So this is a talk on bovine Besnoitiosis. It's just been diagnosed last year in this country, and I suppose it was a disease that would have been considered exotic up until relatively recently, and still would be as well across in the UK, although I'm sure there's lots of people from lots of countries here in Europe where it's quite endemic. So I'm presenting this on behalf of Catherine Carty and Alison Lee and Joe Cassidy and members of the department, Marissa Sheehan and Alan Johnson, and also help from Gary and Charez from Germany as well. Okay, so I thought I'd just do a little bit of a review of bovine Besnoitia to start with, seeing as it's not endemic in a lot of countries in Europe, and it's an emerging disease, as you would say. So Besnoitia, or caused by Besnoitia besnoitii, it's a member of the Sarcosistidae family. So it's a protozoan parasite of the skin, same family as Neospora, which we're all much more familiar with. The actual host, or the definitive host, is not known. Might be the bat, might be the cat, not sure, but it's of that family as such. And it's a disease, basically, that pretty much is characterized by three different stages: an acute stage, a subacute, and a chronic stage. So the acute and the chronic stages are the two clinical, I suppose, manifestations which you would look for. In terms of the acute stage, like with most infections, there's a slight lag period. So after about 10 days or so, the acute stage will kick in, and that lasts for about a fortnight, on which the tachyzoids of this protozoan parasite, they tend to work around the body, and they have a tropism for immune cells and also for endothelial cells of blood vessels. And one thing you'll see here there's numerous clinical signs which are associated with the acute stage, but one thing that's very noticeable is that a lot of those clinical signs are pretty non-specific, which is one of the reasons why it can be difficult when it gets into a naive herd, particularly in a herd or in a country where it's a disease that you wouldn't be looking for, that it can certainly be easily missed. I've highlighted in red here the clinical signs which Michael O'Mara in Gertland Rowe and the other vets in his practice would have come across and would have associated most with it throughout the last number of years. So typically we're seeing animals with pyrexia, drop in milk yield across the dairy herd, and a lot of the clinical signs were associated with upper respiratory tract disease. So you're talking about a lot of clinical signs which looked a lot like IBR. You also had raised lymph nodes, and a lot of animals were showing stiffness due to swellings around the legs, maybe some swollen joints. So that typical appearance of upper respiratory tract signs and also stiffness and swollen joints, that was quite typical in that herd. So the major differential diagnosis that you would think about if you're looking at those signs would be likes of IBR. So that's something to keep in mind. And there was actually IBR circulating in this herd as well, which made it a little bit more difficult. The chronic stage then is probably the stage which is most classical for the disease. Now, generally speaking, only about 1 or 2% of animals will ever develop into this chronic stage, which is a stage associated with thickening of skin and also the development of cysts. Of these parasites develop into cysts which can be visualized with the naked eye, and they tend to be present in particular parts of the body. In terms of the actual major clinical signs, it's really the thickening of the skin around the head, the neck region, and particularly around the legs, which is often very obvious. And in this herd was a milk and dairy herd, and so these changes in the skin were most obvious in the white parts of the body. And because of that, then photosensitization was obviously the first clinical sign which would have come to mind as a differential diagnosis. As well as this, then, those animals that tend to develop the chronic stage, while some of them do tend to improve quite a lot over time, some of them will also show a lot of body condition score loss, and there are mortalities, and there were mortalities in this herd as well. 1 or 2 certainly the first couple of years had to either be euthanized or would have pined away to such a stage that they ended up being euthanized. One thing that's pathognomonic about Besnoitiosis in cattle is that after the initial acute stage and the subacute stage, you get the development of cysts in a high proportion of animals in the scleral, or we'll say the bulbar conjunctiva of the eye. So around the white margin of the eye, around the iris. You'll see these white cysts, and I'll show you some photographs of those later on. So if you're doing a clinical examination or investigation on the farm, this is something from the clinical point of view that you would look for quite strongly. So they're pathognomonic really for this disease. So the major differential diagnosis in the chronic stage then would be the likes of photosensitization, whereas the major differential diagnosis in the acute stage, particularly with what was seen in this herd, would have been upper respiratory tract disease like IBR. This is just showing one of the worst affected cows in this herd, and you can see the white parts of the skin most obviously affected compared to a photosensitization case. So you can see quite obviously that they certainly could be mistaken for each other. Besnoitiosis, the economic losses associated with it, they definitely vary depending on whether it's a naive herd or whether it's a herd that's endemically infected with this disease. Abortion certainly can occur, wasn't really seen much in this herd, but certainly the chronically infected animals, of which is a small number, certainly will lose weight. This farmer also kept his male calves and would have fattened those. A proportion of those male calves would not have made good weight, and so they would have lost out from that point of view. But what the farmer himself would have most obviously noted would have been the drops off in milk yield. He would have had somewhere between 10 and 20 animals in the earlier stages, the first couple of years of this, where he would know cows coming in, dropping in milk yield, and that milk yield taking somewhere between 10 days up to sometimes 3 weeks for that milk yield to fully recover. So there was certainly an economic loss associated with that. So this investigation came about because Mike Mara and his team in Gertland Row had been looking at this herd for a couple of years, and they had been initially looking at this disease perhaps as an unusual photosensitization which wasn't responding. But because it wasn't responding, then they decided that they'd take further investigation steps. So in terms of the investigation itself, the dairy herd was a herd of about 120, 150 cows, and we investigated it, let's say, last summer of 2015. And we went through our standard, let's say, herd health approach, where you get your history and you're trying to find out a case definition for the clinical cases and try and get some patterns of time and space and groups and how this disease was occurring over the years. So what we found out was that the first obvious clinical cases probably dated back as far as 2010 in this herd. And typically speaking, this was a summer disease, so a disease that occurred mainly from March time onwards, so a disease of the summer time, again, something that you would maybe associate with a photosensitization type thing. There were certainly some mortalities, as I said, but the milk drop syndrome was very marked in this herd. There was also these IBR-like signs, but also there was IBR circulating in the herd as well. So this is just showing a timeline of the cases divided into the acute cases, which would be the cases of cows, which we probably could say would either have had one or a combination of upper respiratory signs plus milk drop syndrome. The majority would be the combination or one of the two. And also in the blue bars there you see the chronic cases. So the disease may have started back in 2010 based on what our clinical findings were, with a peak around 2012 in both acute and chronic cases. The number of acute cases seems to be slightly on the decline since then, probably because the herd now has become endemic. And you can see that there's a steady 1 or 2 animals per year becoming chronic. This is an example of one of the worst affected animals in the herd. So you can see animal had lost a lot of body condition. This animal was milking only about 10 litres a day, 10, 12 litres a day at this stage, even though she would have been a spring calving cow. A lot of the cows which we got into the milking parlour, there would have been eight cows on that day there. A lot of them would have had these classical clinical signs, which were most obvious on the back legs. So this is a very obviously affected one here, where you can see these large raised sort of lumps of skin down along the back legs, up not just in the white areas, but you can see in the dark areas as well, wrinkling of skin here on both sides. Other was affected in a number of animals. Some of the bulls, you could see the scrotal skin as well, which is also thickened. So this is just a close-up of that there. And unlike, I suppose, unlike photosensitization, sorry, I'm picking the wrong one. Unlike fossilization, this would not have been sore to the touch. It would have been hard and firm, firm nodules in the skin, really, I suppose is what you would describe it as. So we came to investigate, I suppose, unusual photosensitization outbreak on a farm. But when we talked to Michael, he would have thought that this probably was something different and more so than just photosensitization. So as part of our investigation, and because of the appearance of the skin, we took skin biopsies, and it was really these skin biopsies which led to the diagnosis. Joe Cassidy and his team in UCD would have looked at the slides and they found it was the classical dermatitis which you would get, granulomatous eosinophilic dermatitis associated with cutaneous Besnoitiosis. And on the histopathology, this is what is classically seen. So throughout the dermis of the skin, in these affected areas where you've had these lumps, you'll see these numerous cysts. So you've got these thick double-wall cysts, and within those then you'll have huge numbers of tachyzoids. And it's just the build-up of all these cysts which cause the hardening and the thickening of the skin in those affected areas. So you have numerous amounts of parasite cysts throughout the body. So we went back then, the team together. We had members of the Department of Agriculture and our own team as well together, and we went back together with Michael, and we decided we'd just assess the herd from the point of view of, just to confirm it's an endemically infected herd and to see what level of disease was present. So if you were looking at Besnoitiosis just generally, from a general point of view, the obvious chronic cases are fair enough to diagnose. You could basically diagnose those and clinical signs together with skin biopsies. But really, if you're looking at animals, the majority of animals in a herd would not be chronic, as I said. The majority of animals in a herd would be asymptomatic. So acutely affected animals, again, hard to diagnose. But a lot of asymptomatic animals might have those cysts on the eyes. So they might have got over but not become chronic. But in addition, if you're investigating a herd, serology is very important. And so we investigated some serological tests, and then we got in contact with Gary and Charez in the FLI Institute, which have done a lot of work on this. So on the day of the investigation, 228 animals in the herd were examined. So eyes were checked, vulva was checked in the female animals. Animals were blood tested as well, and those were sent off to the FLI Institute in Germany. And one severely affected animal then was taken back for euthanasia. So just some photographs then of things. So some animals, it was quite obvious you could see skin thickening, but skin thickening wasn't all that marked. There wasn't that many animals in the herd where you could say it was very obvious skin thickening. Picking up vulvar cysts was one thing that I think across the board, talking to Marissa and Alan Johnson and other people, that we would all agree that was quite difficult to be sure, when you were saying vulvar cysts or not. But what was obvious was scleral cysts. So scleral cysts are the cysts on the bulbar conjunctiva of the eye. They were certainly very characteristic. I think they'd be really the pathognomonic sign that you would look for in the clinical examination or an investigation of a herd like this. And so you can see here all these raised cysts along here. So this is a very nice photograph taken by Alan Johnson. In terms of the actual results then of the serological study, 89% of animals that were tested were positive, and across that then there was definitely a difference in terms of age. So 60% of first lactation cows were seropositive, and as cows got older in the herd, they certainly were more likely to be positive, indicating the disease was present in the herd for a number of years. Again, in terms of sclerocysts, 50% of animals had sclerocysts, 65% we would have thought would have had vulval cysts based on our investigation. In terms of date of birth as well, we looked at it that way, and certainly you can see here that the young calves of that year, none of those came up seropositive. Yearling heifers, 30% came up seropositive, and as you get older in the herd, then certainly the older animals certainly more likely to be seropositive. And the same again, that sort of held true across in terms of sclerocysts and stuff as well. So it's a disease that spreads slowly in a herd. Takes time because in terms of contact, direct contact is very important for the spread of this. This is the animal that went back to UCD for clinical examination, and also then that went for post-mortem examination. And you can see this animal was certainly severely affected, had that classical thickening of the skin here. You can see the neck and the head area here, really markedly affected. Here you can see as well this animal had the classic cysts on the eyes. So you can see all those little small white little dots there. They would be sclerocysts. And this here is the This here is on histopathology, a cross-section of one of those scleral cysts, just showing that within those individual cysts, you'd have a number of smaller cysts containing tachyzoids. One thing that was very obvious in this animal, and Michael and the farmer had both said that she had displayed for quite a long period of time some upper respiratory tract signs, sometimes quite marked, sometimes less marked. But throughout her upper respiratory mucosa, all the way down into her trachea, you had numerous cysts. So it had a very, very roughened appearance, very, very roughened appearance. Down along here. You can see numerous cysts in the upper respiratory mucosa, which would have fit with a lot of the clinical signs of upper respiratory disease. And there were cysts throughout a lot of different tissues in this animal. So the inside of the teeth, corium of the solar corium as well, the tongue, many other tissues. Here we can see cysts here in the tongue, and you can see a cyst here breaking through a blood vessel wall as well. So these are examples of all the different tissues in that animal, all the different tissues that had cysts as well here. So all the way down to the lung, certainly the solar corium, the teeth canal. So numerous different cysts, numerous different tissues affected as such. So in terms of the implications of this discovery, really, I suppose it just highlights that Besnoitiosis, like a number of other diseases that have been discussed this week, like blue tongue and various other diseases like that, lumpy skin is mentioned recently. Besnoitiosis is one of those diseases that's emerging across Europe. And it's been seen since 2001 that it's spread quite a lot. There's a number of countries now across Spain, Portugal, France, Italy, all the way across there, even to Hungary, where it's almost become endemic now. And Germany, Switzerland, they've had their outbreaks. Arnie Van Oud published a case there last year in Belgium as well. So it's been in quite a number of countries in Europe. This is going back to 2013, and since then, as I said, you'd have to add in Ireland, you'd have to add in Belgium, you'd have to add in Hungary. So it's tipping along nicely into a lot of countries across Europe. How it's getting there then, there's a number of questions that have to be answered. How did it get into Ireland, basically? And these herds that have it in Ireland now, this one herd we know about, has it spread to other herds? They're the type of questions which we're trying to answer at this stage. So typically, pretty much it gets into herds, usually in most of the countries, it's been purchased into those herds, like Switzerland, Germany, is via the purchase of animals into those herds. We've got some preliminary investigations, and we have found some imported cattle which look like very, very close to this herd, which look like they have clinical signs. So it probably was imported into this country, into a local herd, and spread that way as well. What is noted in this herd is that natural mating, close contact between animals, is probably very, very important in terms of how it's disseminated throughout the herd. Vector transfer is noted as being very important, tabanid flies, horse flies in particular, and there's also a possibility of iatrogenic transfer via needles, etc. So that's something to keep in mind if you're dealing with one of these herds. Just to pay tribute to all these people here in the Besnoitia Technical Working Group, particularly led by Dave Quinn and chaired by John Griffin, which are really doing most of the work in terms of following up this investigation now, and particularly David Quinn. So I'll finish up with that. We're going to look at the herd. We're going to look and see if there's other herds around. I think Michael Maher himself has already diagnosed a second herd, so we know there's more than one herd in that region now with it. Thanks very, very much.
Okay, it's unfortunate that we've run out of time.